Alright, so now that we understand what are number sequences and how lovely they are, so let's try to understand the general term. And I will be explaining what general term is, and I will be explaining how to use that in order to find any missing, term in any sequence. So this video is about the general term. Right. So for example, let's come up with a very simple sequence, which is like uh, the simplest of all. For example, you could just say 1, 2, 3, 4, 5, right? So you know that this is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term. What would be the sixth term, and what would be the any term? For example, hundredth term, right? And then we just need to find out this nth term, that like any term. N means any, right? So yeah, we can do it simply. First term is 1, second is 2, third is 3, fourth is 4, fifth is 5, 5, and 6 would be just 6, just following common sense. 100 would be 100, and nth would be just n, and when n is equal to 1, right? So n is, n is whenever n is basically the number of term, this number could be considered as n. If n is 100, then the term is also 100. If n is 6, then this term is also 6. So whatever this number is, the term is also that. So if we want to find nth term, it should be n. Just speaking in the language of algebra and mathematics, right? Let's come up with a tougher sequence like this: 2, 4, 6, 8, 10. What would be the sixth term, a hundredth term, and an nth term, right? So it's pretty simple. All we need to do is follow the common logic: 2, 4, 6, 8, 10, and the next would be 12. And as we know that the first term was 2, second term was 4, third was 6. So whatever the number whatever that term is, we just need to multiply with 2. 4, like fourth was 8, fifth was 10, sixth was 12. 100 must be 200, right? And what would n be? N would just be 2n, because we just need to multiply that term with 2 in order to get. So we just need to have any term n, and we just need to multiply with 2 and get a 2n. So we just first of all observe a logic, and then translate that logic into the language of mathematics via this nth term sequence, right? So the next could be like this. For example, I could just write a sequence like, um, let's say 1, let's say 4, let's say 7, let's say 10, let's say um, 13, and these are the first 5. And what would be the sixth, what would be the hundredth, and what would be the nth term? Okay, this is a pretty more complex than the first two what that we did. So we can see that 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10. So we are adding 3 into the every number, and we are getting the next number by just adding 3 to it, right? So what would be the hundredth term? For that, we just need to develop a sequence, because we can't be just calculating 16, 19, and then 22, and then 25 all the way up to 100. So there has to be a specific way. For that, we need to find the general term, the nth term. If we know the nth term, we are able to solve it easily, right? So the first term is 1. Okay, we have 1. The second term is 2, but we have the second term is actually 4, and the third term is 7. The fourth is 10, and the fifth is 13, and the sixth is 16. How we can actually approach this? We can approach this by developing a common logic. So what is the logic that actually relates these numbers to the number of terms, right? So how do we do that? First of all, since it's a linear sequence, like we are adding 3 into it, it's a linear sequence, it has to be involving an n. But in order to get to this, like first is, okay, first term is 1, but second term is not 2, it is 4. So we are adding 2 into the second term, right? So what we can do here is that we can multiply it with 3 and then subtract 2, right? So let's see if it makes sense or not. So first term is 1, and we multiply it with 1. 3 times 1 is 3, minus 2 is 1, we get 1. The second term is 2, and we just multiply it with 3, we get 6, minus 2, we get 4. Fine. The third term is 7, so we multiply 3 with, uh, you know, 3 and we get 9 and then we subtract 2. So how did I eventually get reach to this conclusion? It works. It actually works. The n term is 3n minus 2. How did I reach to this conclusion or result? The first thing is, of course, by experience. I've been solving a lot of sequences, so I just solved it almost on my instincts. But the standard way to do is you just need to find if the sequence is linear or exponential. If it is linear, like we are adding 3 into every single term in order to get next, there has to be 3n involved. That is a key or a hack that you can call it in order to find it. So you're adding a 3, that is why there has to be 3n. Or you can just see it this way. You just need to add a 2 into, if you just add a 2 into all of these terms, then this will become 3, this will become 6, this will become 9, this will become 12. So you see it's a timetable of 3. So there has to be 3n, because the general term for the timetable of 3 is 3n. So if you just add 2 into all of these terms, the general term would be 3n. But this is not actually like that. The 2 is, it is 2 less than all these numbers, like 3, 6, 9. The timetable of 3 is there, but every term is 2 less than that. It's instead of 3 it's 1, instead of 6 it's 4, instead of 9 it's 7, instead of 12 it's 10, instead of 16 it's, sorry, 15 it's 13, instead of 18 it's 16. So it 2 is subtracted from all these numbers. So from the timetable of 3, it 2 is subtracted. So you can just approach it this way in order to reach to this general term, right? So I did it almost on my instincts, uh, because of experience, because I knew there has to be 3n, and then I just need to subtract 2 in order to get numbers that I could see in the first 2 or 3 parents, and then I just checked it and it actually worked. But the general principle or tactic to solve or find the general term goes like this. You need to see if it is linear or not, and then you just need to see, okay, since the difference is 3, the difference in the numbers of the timetable of 3, 6, 9, 12, 15 is also 3, but these terms are actually 2 less than that. 1, 4, 7, 10, 12, so 2 less than that. So timetable of 3, whose done general term would be 3n, we just need to subtract 2 from this because all the terms are 2 less than that. So 3n minus 2 would be the nth term, and in order to find the 100th term, we just need to put in 100 for n. So 100 times 3 is 300 minus 2 is 298. So the 100 term would be 298. So that's how you actually find the general term of a sequence in order to find any nth term of that sequence.